We've covered what predictive analysis is, and we've covered some basics of big data. So now let's talk about why would we need big data in predictive analysis. Now, I'm going to start this off by saying that there are situations in which we don't really need to engage in predictive analysis. For instance, small businesses more than likely don't really need to predict those things. They don't need to worry about those situations. And there may be, like with human behavior, even though predictive analysis is very useful, one of the things that I do kind of as a hobby on the side is predict human behavior. And I do behavior training, and I have people send me their tweets. I'll analyze their tweets, and then I can tell them things about themselves and where their strengths and weaknesses are. That way they can leverage their strengths. I use predictive analysis with their tweets, but it's a very small set of data. So big data isn't necessary for predicting human behavior or for providing even feedback on human behavior. Small data can work there. But there are examples where it does. And so anytime we deal with something like big data or predictive analysis, and I've seen this all over the internet, Americans, I've lived in America for a while, so if you're from another country, that's awesome, it's really great, but let me tell you a little bit about Americans. They love to be one extreme or the other, and the media, they love to feature those extremes, okay? So you're going to find people who think big data is the worst thing in the world, and there are going to be people who think it's the best thing in the world, and you're never going to really have very moderate views. And that's just kind of the way it works in the US. Same thing with predictive analysis. Oh, it's the greatest thing in the world. And then you're going to have people who think it's the worst thing in the world. I agree that it's not useful for every single business out there. It's not useful for every single problem. But I think some of the bigger problems, let's say medicine, and I think problems like energy, predictive analysis would be very useful. So let's go and let's use an example of how we could use predictive analysis in a medical example. So what I want to do here is let's highlight, let's go back to our example, I believe it was in big data, the big data video and the predictive analysis video, where we're talking about a young man in his 20s who had prostate cancer. And let's suppose that we're looking at that set of data and we look at his family, and nobody in his family has ever had prostate cancer. So we know that the way that the doctor's looking at it, it's already limited. So how can we use predictive analysis if we have a big set of data? Now I'm going to use a small example, but imagine in this little chart right here, if we had multiple values of people in their 20s, and we had details about them. So DHT, for instance, this measures dihydrotestosterone. So that's a form of testosterone which is very anabolic, but also can be associated with risks for prostate cancer. We look at whether these 20-year-olds are sedentary or not, right? Are they moving around? Are they active? We measure whether they're on a high carbohydrate diet. We measure whether they eat very few vegetables. For instance, things like tomatoes are more likely to prevent prostate cancer. There's probably a lot of different vegetables out there that are more likely to prevent prostate cancer. But generally speaking, people who have cancer, not always, but generally don't eat as many vegetables as people who have cancer. And then we look and see whether they actually have prostate cancer or not. So when we look at this, and imagine if, again, we had thousands and thousands or millions of these values. When we begin to look at this, we see, okay, so this 20-year-old, he has high DHT, sedentary, high carb, few vegetables, prostate cancer. This one, the only exception is he was eating a lot of vegetables, but he had high DHT, he was sedentary, he also had a high carbohydrate diet. This 20-year-old also had everything here. This one also had everything here. And this one also had everything here. Now, with big data, we can have a computer do all this. I mean, imagine if we were looking through all this, it would be very difficult. But we could apply algorithms that would then, because this is the 20-year-old in question, we're wondering, okay, hey, we just found in the population that this 20-year-old meets all of these other criteria here, but he doesn't have prostate cancer yet. So what is his probability based on these other data that he's going to get prostate cancer? Now, why is that important? Well, think about some of the factors. Now, high DHT, I don't really think it's a good idea to limit this. A lot of people would think so, but I don't think so. This is very anabolic. This is a very effective form of testosterone, so it has its uses. But you can limit this. You can limit this. You can limit this, right? In other words, if you're eating few vegetables, you can eat more vegetables. If you have a high carbohydrate diet, you can go to a lower carb diet and a higher fat diet. If you are very sedentary, you can become more active, right? So we can eliminate these factors and think about it for this individual here. Imagine if, let's go ahead and erase it, if this individual, we removed this X and we removed this X, now what's his probability of getting prostate cancer? Based on these other data, and then what we would want to do is we would want to look at 20-year-olds who just had high DHT but weren't sedentary, didn't eat high carb diets, and didn't eat few vegetables. They ate a lot of vegetables, okay? So anytime someone comes along and is like, well, big data is just not useful, and this is why I'm not a huge fan of people like critics, but Americans love critics, it would be very useful in this situation, because the problem with this example right here is that we only have 1, 2, 3, 4, 5, 6, 7. Well, and we're using this one off these other 6, right? What happens if we had millions of records? We could start predicting things with fairly good accuracy. So big data has huge impact on, and with predictive analysis I'm saying, it has huge impact in things like medicine. We don't really know these things, and it's sad to say this, but again, the majority of really big hospitals out there and big medical communities, they're not really interested in this. They're not really interested in tapping this power, and it's sad because there's a huge gold mine here. Other examples of this is, let's say, energy. So humans are highly dependent upon energy. It's very difficult if you're an engineer to know every single possible outcome of every method you use to approach producing energy. There's a lot of controversial energy approaches. For instance, ethanol. Depends on who you ask, but a lot of individuals will bring up that ethanol is not very energy efficient compared to oil. Oil provides a lot of energy, and the cost to get oil is much less than what it provides as far as energy. But imagine if we had all of the data in front of us and we had computers going out and mining this. They could identify potential solutions. So when we're talking about major problems, we're talking about cancer, we're talking about medicine, we're talking about energy, big data and predictive analysis will have the biggest wins there. When we're talking about very small issues, it's sad, but where do you think big data is most used in? Yeah, it's like, do your customers bought this video? That means they might be interested in this video over here. I mean, I agree. That's what most people think when they think of predictive analysis. But that's the least helpful of where big data could be useful at. And so, since we're not really applying it in medicine and we're not really applying it in energy, it's very easy to be a critic of both predictive analysis and big data. But as more people get into the medical field and the energy field and they apply these predictions and they apply that with data sets, you will find that we're able to solve much bigger and bigger problems. And think about the fact that, again, just like the example, when we have a small set of data, it's very hard to predict anything. A doctor is just using his or her intuition if he or she deals with a 20-year-old who has prostate cancer, based on how many clients of his or hers has had prostate cancer. And that's a very small set of data compared to the entire population of the world. And so when we can look at a data set like that, we can start to identify these risk factors, these genes, etc.